So welcome to 5.2, where we talk about reciprocal trig. So we know these three basic trig functions: sine, cosine, and tangent, where we set the ratios of two sides. Trig functions are just ratios of sides. It becomes a bit tricky when you have negatives and when you have zeros, but for the most part, trig functions are ratios. That being said, since we do have these fractions, we found a purpose and a use for the other way around, the reciprocal. If we have hypotenuse over opposite, if we have hypotenuse over adjacent, we found that there is use for it. So we want to be comfortable using these reciprocal trig functions. And these reciprocal trig functions are as follows. With sine, we have cosecant. Cosecant. Also write here cosecant. S-E-C-A-N-T, cosecant. Cosecant of theta is equal to 1 over sine. Secant of theta is equal to 1 over cosine. And cotangent of theta, C-O-T, is equal to 1 over tangent of theta. These are useful, but we'll talk about its use in a little bit. So now let's see how we want to apply it in the scope of this class, in the scope of our unit. We use these when we want to solve problems. Let's say, for example, we've learned so far that you could solve for a sine of theta equals like 0.4. We know how to solve for this. So we could use these in the same way. Where we want to have secant of theta is equal to like 2.7. Now we're going to see what is the restriction on this. So let's actually work on it first, and let's see what the restrictions might be. So to solve this out, to solve out reciprocal trig function problems, when we have it set up like this, when we have our secant, the theta is 2.7, we want to convert it back into our basic trig functions. We want to convert it back to sine, cosine, or tangent. Because on your calculators, this one's a bit different. You will probably only have sine, cosine, and tangent, as well as inverse sine, inverse cosine, and inverse tangent. This computer does have both, but you will not have that for your test. So we're going to get used to manipulating these functions. So to convert it first, I want to see what can I turn secant into. Looking at my properties, my reciprocal properties, I see that secant is actually 1 over cosine. So I change it off. So I have 1 over cosine of theta is equal to 22.7. I didn't change the right side at all. I just replaced the left with something that is equivalent, something that is the same. Now, I don't like solving this out. I can't solve it with cosine at the bottom. So what I can do is I flip everything. We'll actually go through the process first. So one way we could solve it out is get rid of cosine at the bottom, is I cross multiply. I multiply cosine, both sides by cosine, and multiply both sides by 1. So I have 1 equals 2.7 cosine theta. And then to get the cosine by itself, I divide by 2.7 to get 2.7, or 1 over 2.7 is equal to cosine of theta. To skip all this, to go from here straight to here, what we can do is flip everything. Flip both sides. So I flip this to be cosine of theta over 1 is equal to 1 over 2.7, which is equivalent. That is the same. This process is allowed. You are fine to just skip the process and be like, I get to here first, I replace secant with 1 over cosine, and I flip everything. So cosine of theta equals 1 over 2.7. 1 divided by 2.7. Let's just give a rough estimate of what that is. 0.37. Oh. Cosine of theta equals 0.370. If you recall, our requirement for cosine and sine is that our result must be between -1 and 1. And 0.370 is less than 1. It is in between that interval. So what we see is that our result here must be in between -1 and 1. So when I divide by a value, when I flip it and might divide, my secant and my cosecant, the ones that correspond with sine and cosine, it must be greater than 1. Because I must do 1 divided by a value. 1 divided by that value. If I do 1 divided by 2, we see that I get 0.5. 1 divided by 1.5, I get 0.6. However, if I do 1 divided by 0.9, once I dip below 1 for a secant and cosecant, I end up with a value bigger than 1. So that's something that you could keep in mind. It is not necessary, because you could just spot it at this point. If you spot it here, you could obviously double check your math. Maybe something went wrong. But if you're still getting this, if you still get, for example, like cosine of theta is 2.7, and that doesn't work, double check your math. But there's a chance that it's just out of your range. You can't get that value. It is impossible to get. And that is okay. So this is how we solve for reciprocal. When you have reciprocals, you replace, you flip, and you solve like normal. So I do inverse cosine of 1 over 2.7 equal to theta. For cosine, I see I have quadrant 1 and quadrant 4 for when it's positive, and we can solve it out fully. I will solve this one out just to double check. Let's do 1 divided by 2.7. Inverse cosine of this. It's in degrees. 1 divided by 2.7. Inverse cosine gives me 1.191. Theta is 1.191. For quadrant 1, I'm fine with that, 1.191. For quadrant 4, I must have 2 pi minus theta, 2 pi minus 1.9191. I forget where I paused from, but I think I paused from plugging this in the calculator. So 2 pi minus our angle would give me 5.092. And I rewrite it, that's my final answer. Now, we learned before we could check this. In 5.1, we could plug in our value into our original, because we have tangent, we have sine, we have cosine. But we don't have secant, we don't have cosecant, we don't have cotangent. So in order to check it, we want to look at where we can. The first place where we can comfortably. I can't plug in here. I can plug in here because I do have cosine. We could also plug in here because like plugging into 1 over is a bit uncomfortable to do, but it is doable. So let's actually clear it out. Let's do 1 divided by parentheses cosine of 1.191. So 1.191 cosine. And I see you get 0.370, which is what 1 divided 2.7 is. And that's great. We got it. Let's also try our other one. Let's clear everything. 1 divided by parentheses 5.092 cosine of that, and get 0.37 just like this. So we see we are able to get it, we're able to check it. It's a bit trickier to check. It's not the perfect check because we're not checking the original, but we are able to check. So that is how we do reciprocals. We, just before we get it to this form of our trig function is equal to a value, we substitute it in, we flip it, and now we treat it just like normal. If you want to, you can just divide this out and use a decimal because you should be comfortable with decimals at this point. At this point, that's barbecue chicken. We're able to just solve this out. All right. Next up is 5.3, and there's a lot to do with 5.3.